Hi guys. So I'm just gonna do these things. I'm gonna do a few questions out of each thing and explain it as I do it and hopefully let you clarify. I'm gonna start by doing these bottom two because these bottom two are the more sophisticated ones. Okay, let me just try to move it down to the thing. Okay. So this is 5x plus 5x over x plus 3 plus 15 over x plus 3. So when you add fractions, if they have the same denominator, you can just add the numerators together and you'll be fine. So this is equal to 5x plus 15 over x plus 3. So that's great. That was easy. Well, that's how it seems at first. But the reality is that it's a little bit more complicated, and if you'll see why, because this 5x plus 15 can be factored out into 5 times x plus 3, because 3 times 5 is 15 and x times 5 is 5x, and that's all over x plus 3. And what we see now is you have an x plus 3 down here and an x plus 3 up here. So act like they cancel each other out. They're all gone. And so this whole thing actually equals 5, amazingly. So that's the thing to take care of. Sometimes you won't have a factor down there, but sometimes you will. So just keep in mind that you got to do that in order to ensure that everything is simplified, finding the sum or the difference. Okay, I'm going to do the other one on the bottom. This other one on the bottom is 4x squared over 2x minus 1 minus 1 over 2x squared minus 1. So we know how to do that because they have the same denominator. You just turn that into 4x squared minus 1 over 2x minus 1. So the thing is about this is that it's the difference between two squares. And the thing is that can be turned into 2x plus 1 times 2x minus 1. And that's the thing that we gotta figure out. I think I went over that in a previous video, but that's a specific type of quadratic function that you got to remember, because it can look like a really simple just this minus this when it can actually be factored out into something greater. And that's all over 2x minus 1. And then just cross these out because these two factors are there. They're a thing and they cancel each other out. And then the actual difference is 2x plus 1. Okay, let me zoom out. Woo. Now I'm gonna do finding the least common multiple, which should be pretty fun. Put it down. Zoom back in again. So finding the least common multiple for stuff is not as difficult as it looks, because I know it's a variable that it's difficult to do, but it's not actually. It's actually so easy. Let's do it. The way that you find the least common multiple of two numbers is that you first factorize each term. So for example, 3 times x is equal to 3 times x. So the two factors of this are 3 and x. And 3 times x minus 2, the two factors of that are 3 and x minus 2. Now, the thing is, if we sort of shove, well, there are 3 factors present. There's 3, x, and x minus 2. Even though there's 4 factors total, this 3 is repeated. So there's only really 3 factors present, essentially. So you can turn that into 3 times x minus 2. And then what that turns into is 3 times, just doing math in my head here, x squared minus 2x. Yeah. And then that is equal to, when you distribute it even further, 3x squared minus 6x. And this is the least common multiple. So you factorize the numbers and you break it down. You only use the amount of factors when they're not repeated. So we don't do an extra 3. We don't put in this extra 3. If it's repeated, just include all of the factors that are ever featured ever, and then just multiply them all together, and then you get the least common multiple. And the thing is, since this is like 3 times x minus 2 and this is 3 times x, when you sort of shove it together, not including the repeating factors, you have both of them kind of wedged in there. And that's why this is the least common multiple, because it's 3x minus 2 times 3 because it's these minus 2, and it's 3x times x minus 2 because it's a multiple of both of those things, the least common multiple. I'm just going to do another one because why not? Just to get you familiarized with it. So, okay. X squared minus 25. That was one of those quadratic functions I was talking about. So that can be factorized down to x plus 5 times x minus 5. And this is just x minus 5. Because this can't be broken down to like multiples, to factors, sorry. So you got x plus 5 times x minus 5 and x minus 5. So we don't do repeating things. So the least common multiple is x plus 5 times x minus 5, which ends up being x squared minus 25. So the least common multiple ended up just being this. And that'll happen sometimes. That can happen. Sometimes in life. I don't know where I was going. And so just do the last one. This is a quadratic function. You can factor it. I think it's x plus 5 times x minus 8. You'll factor it later. And turn this over. And then the big thing here is, let's see, making an argument. Your friend claims the least common multiple of two numbers is always greater than each of the numbers. Is your friend correct? Well, we saw from the earlier... Oh, God, I'm going to have to turn that. We saw from the earlier thing, the earlier example, that the least common multiple is not greater than each of the numbers. Sometimes it's equal to the number that's just bigger. So we'll write that. We'll write no. Sometimes the least common multiple is equal to the greater number. And another example of that would be just for like regular numbers, just not including all of the x's, would be 6 and 24. The least common multiple of 6 and 24 is 24, because 24 is a multiple of both 6 and 24. So like when the bigger number is a multiple of the smaller number, the least common multiple is just going to be like this number, because like this number is a multiple of that's yeah. So the least common multiple of the two numbers is not always greater. So you say no. Yeah. That's all I'm going to do. I was just going to do least common multiple. I realized there's other stuff on the homework. I'm sorry I couldn't get to that. But that's it. That's it. Goodbye.